that kind of a mood to go to a semi-sleep condition. So I would try to make it as entertaining to you as possible. So what I am focusing here is blockchain and Bitcoin basics. So let me introduce you. My name is Harsh. I am a certified Hyperledger developer from Kerala Blockchain Academy, as well as I am working as the Chief Technology Officer for MACB, which is incubated here at ASIT TBA. Okay, so before I start, I would like to show you a little video which explains about the basic working and the basic technology behind blockchain. So let's get into that. So I guess everyone is okay with Malayalam, a little Malayalam between, okay?
Ever wonder if there's an easier way to complete transactions without having to deal with online wallets, banks, and third-party applications? Well, it's possible thanks to blockchain. Here's everything you need to know about blockchain. Imagine 4 friends, Jack, Ted, Sam, and Bill meet up for dinner. After they're done, Jack pays the bill, and all of them decide to split the expense amongst each other. Now, on the next day, when Bill sends his share to Jack via online money transfer, the transaction goes through without a hitch. Then Ted and Sam send their respective shares to Jack, but their transactions don't go through. The Bill transaction cites some issues at the bank. That's when Jack comes to know about the many ways a bank transaction could fail. It could be due to technical issues at the bank. One of their accounts were hacked, daily transfer limits being exceeded, and sometimes additional.
So here the video starts with a simple problem statement. So guess 4 of you or 4 friends went to dinner at some place. So the problem is ഇപ്പോൾ നമ്മൾ എവിടെയെങ്കിലും ഡിന്നറിന് പോയി ഒരാൾ സ്പെസിഫിക്കലി 1 person പേ ചെയ്യും. സോ നാച്ചുറലി ബാക്കിയുള്ളവരെല്ലാവരും ഗൂഗിൾ പേ എടുക്കും, എന്നിട്ട് അവരുടെ ഷെയർ ഫൈനലി വേറെ ആൾക്ക് പേയ്ക്ക് നമ്മൾ അയച്ചു കൊടുക്കും. സോ ആ ഒരു സിറ്റുവേഷനിലുള്ള ഒരു സെൻട്രലൈസേഷൻ പ്രോബ്ലം, ഈ നമ്മൾ ചെയ്യുന്ന the transactions that we initiate, this has to be checked by a central authority. That is, for example, if a single person sends an amount of money to B, then it goes through a central authority, which is, for example, the UPI or another gateway, which is centralized to a single particular bank. So our centralization ഒരു main problem statement ആയിട്ടാണ് blockchain എന്ന concept എടുക്കുന്നത്. So ഈ ഒരു example, for example, if we transfer something through a bank's UPI or a bank's gateway, we are faced with these problems. So these are the many ways a bank transaction could fail. The first is technical issues. If the network is not sufficient, or if there is any other issues while transaction related to network, then the transaction could fail. The second is any hacker who has access to a high-speed network could access your UPI or any other bank details, because these are saved in a centralized server. The next thing is the transfer limit. Google Pay is basically hosted by ICICI in India, but ICICI has set a limit of about 10,000 per day for a ICICI based bank account. So this is a very big problem. For example, if we want to send about 20,000 or 15,000 to someone, we cannot do it from the same UPI ID on the same day. So that is a really big problem. And the last problem,
Charges, like transfer charges,
is high transfer charges. For example, if you are transacting an amount of 1,000 for a single day, so the bank charges you 25 rupees. So consider you want to send that transaction again and again. So if you are doing 4 transactions per a single day, you will be charged with an amount of 100. That's a really big amount if you consider transactions for a single day. So you're just transacting 4,000 and you have lost 100 rupees. So it's a problem which is considered in the blockchain problem statement.
Associated with transferring money to solve these problems, the concept of cryptocurrency came into existence. Cryptocurrencies are a form of digital or virtual currency that run on technology known as blockchain. Thanks to blockchain, cryptocurrencies are immune to counterfeiting, don't require a central authority, and are protected by strong and complex encryption algorithms. And in a market of more than thousands of cryptocurrencies like Litecoin, Ethereum, Zcash,
so from this problem statement, we have a particular solution. This solution called the blockchain technology or Bitcoin technology was proposed by Satoshi Nakamoto. Satoshi Nakamoto is not a particular person. It is a group or a pseudonym for the person or group of people who published the white paper of blockchain. So, നമ്മൾ കൺസിഡർ ചെയ്യുന്ന ഈ ഒരു പ്രോബ്ലം സ്റ്റേറ്റ്മെന്റ് നമുക്ക് eradicate ചെയ്യാൻ വേണ്ടി ഡെവലപ്പ് ചെയ്ത കോൺസെപ്റ്റ് ആണ് ബ്ലോക്ക്ചെയിൻ. So before we start, I would like to provide you with a single sheet of paper which explains 2 basic concepts: the concept of blockchains and the concept of cryptocurrencies. So if you would like, you could distribute. Let's
go
go.
One reigns supreme, Bitcoin. Now, let's go back to our previous example and have Bill, Ed, and Sam send Jack 2 Bitcoins each as their contribution to the previous night's dinner. Let's assume Bill, Ed, and Sam have 3 Bitcoins.
Everyone has received the paper, right? Okay. So if you look at the first page, it shows how a blockchain works, and you look at the back of the page, it shows what happens during a Bitcoin transaction. These are 2 essential factors that you need to know right now. So let's get to the blockchain part. നമ്മൾ നേരത്തെ മറ്റേ UPI വെച്ച് ട്രാൻസാക്ട് ചെയ്യുന്ന ഒരു കേസ് നമ്മൾ എടുത്തു. സെയിം കേസ് നമ്മൾ ബിറ്റ്കോയിൻ വെച്ചാണ് ചെയ്യുന്നത്. So let's see what's the difference. In case of basic bank transaction, നമ്മുടെ ബാങ്ക് അതായത് നമ്മൾ സെലക്ട് ചെയ്തിരിക്കുന്ന ബാങ്ക് ആണ് ഏത് ടൈപ്പ് ട്രാൻസാക്ഷൻ നടന്നു, ആര് തമ്മിൽ നടന്നു എന്നൊക്കെ റെക്കോർഡ് ചെയ്യും. But in case of blockchain, it is entirely different.
It's in reserve. Well, Jack, that's fine. First, Bill sends 2 Bitcoins.
So first you can see Bill sends 2 Bitcoins to Jack. So it's different from a money transaction in case that the money or cash sent is in Bitcoins. So we can say Phil sends 2 Bitcoins to Jack.
To Jack, a record is created in the form of.
Let us see a block there. So inside a block, something is written. It's called a transaction. It is a record of how the data is sent or to which person the transaction is occurring. So we can see that there is a block, and inside a block there is a transaction that records the transaction from Phil to Jack.
Block. The transaction details between them is permanently inscribed in this block. This record also holds the number of Bitcoins each of the friends own. So after Bill's transaction, Jack has 7 Bitcoins, while Bill has 1. Following this, Sam and Ted send 2 Bitcoins to Jack. A new block is created for each of these transactions. These blocks hold the transaction details as well as how many Bitcoins Sam, Ted, and Jack have in reserve. These blocks are linked to each other, as each of them takes reference from the previous one for the number of Bitcoins each friend owns. This chain of records or blocks is called a ledger.
Okay. So here you see a specific word called ledger. It is similar to a ledger that you see in shops. For example, one market, a bunch of shops, you can see a lot of shops there. So each shop, ഓരോ ഷോപ്പിലും ഒരു ബുക്ക് ഉണ്ടാവും. ആ ബുക്കിൽ എത്ര ടൈപ്പ് എങ്ങനെ ട്രാൻസാക്ഷൻസ് നടന്നു എന്നുള്ള ഒരു മണി ഫ്ലോന്റെ ഒരു റെക്കോർഡ് ഉണ്ടാവും. That particular book is called a ledger. So something similar to that is created here. ഇവിടെ ഓരോ ട്രാൻസാക്ഷൻസ് നടക്കുമ്പോഴും it will be written to a block. So ഓരോ ട്രാൻസാക്ഷൻസിനും ഓരോ ബ്ലോക്സിനും മൾട്ടിപ്പിൾ ട്രാൻസാക്ഷൻസും ഉണ്ടാവും. ഓരോ ട്രാൻസാക്ഷൻസും ബ്ലോക്സിലേക്ക് റൈറ്റ് ആവുകയും ചെയ്യും. ഈ ബ്ലോക്സ് ആണ്.
And this ledger is shared among all the brains, which acts as a public distributed ledger. This forms the basis of blockchain. So, what happens when Bill has only one Bitcoin? This chain of records or blocks is called a ledger, and this ledger is shared among all the brains.
Okay. ഈ particular ledger എല്ലാ participants-നും shared ആണ്. So everyone knows how much transactions happen and what type of transactions happen between multiple persons in the chain. So അങ്ങനെയാണ് ഒരു distributed ledger technology ഉണ്ടാവുന്നത്. ഈ കോൺസെപ്റ്റിലേക്ക് കിടക്കുന്നതിന് മുമ്പ് you have to know a bunch of words. So if you could note down these words. The first word is ledger. Ledger എന്ന പറഞ്ഞ കോൺസെപ്റ്റ് നമ്മൾ ഇപ്പോൾ തന്നെ സംസാരിച്ചു. That's the first important part in a blockchain. So the next word is decentralized. Decentralized means it is different from a central concept. So നമ്മൾ നേരത്തെ സംസാരിച്ചു ബാങ്ക്സ് എന്ന് പറയുന്ന ഒരു സെൻട്രൽ അതോറിറ്റിയാണ്. അതിൽ നിന്ന് ഡിഫറെന്റ് ആയ ഒരു ഡീസെൻട്രലൈസ്ഡ് നോൺ centralized concept ആണ് നമ്മൾ ബ്ലോക്ക്ചെയിനിൽ പ്രൊവൈഡ് ചെയ്യുന്നത്. So the next thing is transaction. Transaction എന്ന് പറഞ്ഞാൽ every person initiate ചെയ്യുന്ന ഒരു data sequence. അതായത് for example ഒരു if Phil sends 2 bitcoins to Jack, that data is a transaction. So the next thing is blocks. Blocks are the basic elements of blockchain. So ഈ blocks ഒക്കെ കൂടെ ലിങ്ക് ചെയ്താണ് ഒരു ledger ഉണ്ടാവും. ഈ ledger കോൺസെപ്റ്റിനാണ് നമ്മൾ blockchain technology എന്ന് വിളിക്കുന്നത്. So the next thing is miners, hashing, cryptography, public key, private key, consensus, smart contracts, etc. ഇതെല്ലാം നമ്മൾ step by step we will look into. So when it comes to hyperledger is a private blockchain concept. So അതിൽ നമ്മൾ focus ചെയ്യേണ്ട കുറച്ച് words ആണ് clients, validators, transaction processor, states, blocks and consensus. ഈ കോൺസെപ്റ്റുകളൊക്കെ ക്ലിയർ ആയാൽ മാത്രമാണ് നമുക്ക് ബ്ലോക്ക്ചെയിൻ എന്ന് പറഞ്ഞ കംപ്ലീറ്റ് കോൺസെപ്റ്റിന്റെ ഒരു ഐഡിയ നമുക്ക് ഗ്രാസ്പ് ചെയ്യാൻ പറ്റും. So I guess everyone has noted down. Okay, so notes എല്ലാം വേണമെങ്കിൽ ലിങ്ക് പ്രൊവൈഡ് ചെയ്യാം.
Which acts as a public distributed ledger. This forms the basis of blockchain. So, what happens when Bill has only one Bitcoin left? and he tries to send 2 more Bitcoins to Jack. The transaction will not go through. This is because all his friends have copies of the ledger, and it's clear that Bill has only 1 Bitcoin.
So, ഒരു invalid transaction ഇപ്പോഴാണ് ഡിറ്റക്ട് ചെയ്യുന്ന കോൺസെപ്റ്റ് ആണ് ഇവിടെ എക്സ്പ്ലെയിൻ ചെയ്തത്. സോ ഫിൽ എന്ന് പറഞ്ഞ ഒരാളുടെ ഒരു invalid transaction, that is he wants to send 2 bitcoins but he only has 1 bitcoin. But there is one problem. Everyone in the network has a copy of the ledger, so everyone knows how much transaction or how much that transfer Phil has done. So Phil ന്റെ ബാലൻസ് എത്രയുണ്ടെന്നുള്ള ഒരു ഐഡിയ ഓരോ വാലിഡേറ്റേഴ്സ്, അതായത് ഓരോ നോഡ്സ് ഓഫ് ദ നെറ്റ്വർക്കിന് ഉണ്ടാവും. So that is how an invalid transaction is detected.
Going left, his friends will flag this transaction as invalid. A hacker will not be able to alter the data in the blockchain because each user has a copy of the ledger. The data within the blocks are encrypted by complex algorithms. All of this is made possible with the help of blockchain technology. Blockchain can be described as a collection of records linked with each other, strongly resistant to alteration, and protected using crypto.
So here basic description ആണ് blockchain നമുക്ക് provide ചെയ്യുന്നത്. If you would like to note it down, you could note it down. So blockchain can be basically described as a collection of records or a collection of data linked with each other. That is, ഓരോ transactions blocks create ചെയ്യും. ഈ blocks തമ്മിൽ ഒരു chain network create ചെയ്യും. So they are linked with each other and strongly resistant to alteration. That is, every transaction written in a block is very difficult to change because they are encrypted by hashing technology. So the next thing is protected using cryptography. That is the basic hashing that we have explained. So
Photography. Now, let's have a closer look at the Bitcoin transaction between Jack and Bill and find out how it works. Every user in the Bitcoin network has 2 keys, a public key and a private key. The public key is an address that everyone in the network knows of, like an email address of a user. The private key is a unique address that only the user has knowledge of.
okay, so the next important concept is that of cryptographic keys. These can be called as public keys and public key and private key. Private key is private key. It is only accessible to the person creating the transaction. But public key is a globally accepted key. It is known to everyone in the network. So the public key we derive the private key. So we will discuss it later. We will talk about it later. So these 2 keys are the important keys in any cryptographic system.
Something like a password. First, Bill passes the number of Bitcoins he wants to send to Jack along his and Jack's unique wallet address through a hashing algorithm. All of this is part of the transaction details. These details are encrypted using encryption algorithms and using Bill's unique private.
Right. So we can see that when a transaction is initiated, that means when Phil sends 2 bitcoins to Jack. So that is a particular transaction. A transaction Phil lock ചെയ്യുന്നത് Phil private key വെച്ചാണ്. So that is how a private key is used.
Key. This is done to digitally sign the transaction and to indicate that the transactions came from Bill. This output is now transmitted across the world using Jack's public key. With this, the message or transaction can be decrypted only by Jack's private key, which only Jack has knowledge of. Different cryptocurrencies use different hashing algorithms. While Bitcoin uses the SHA-256 algorithm, Ethereum, which is also a famous cryptocurrency, uses one known as eThash.
So hashing is another concept of So what is used in hashing is called SHA-256. It is a specific type of hashing technology which is widely used in blockchain and Bitcoin technology. So in public networks such as Ethereum, we use a hash called eThash. hashing technology we will talk about it later. So let's get to the basic slides. Okay. So all of you have the document with you, right? So if you take a look at it, let's see a specific transfer of data or a specific transfer of blocks. So let's consider A want to send a particular amount of bitcoins or money to B. So this transaction, this particular transaction between A and B is recorded in a specific block. So this particular block is transmitted or broadcast all over the blockchain network. So particular validators now, the nodes or the computers using the system. അപ്പോൾ ആ സിസ്റ്റത്തിലേക്ക് കംപ്ലീറ്റ് ബ്ലോക്ക് നമ്മൾ പാസ് ചെയ്യണം. ഈ സിസ്റ്റത്തിലെ ഈ നോഡ്സിനെ നമ്മൾ വാലിഡേറ്റേഴ്സ് എന്ന് പറയും. സോ പിന്നെ ഉള്ളൊരു പോയിന്റ് എന്ന് പറഞ്ഞാൽ മൈനേഴ്സ് എന്ന കോൺസെപ്റ്റ് ആണ്. Minus എന്ന concept നമ്മൾ we will talk about it. So after minus approve the transaction, this transaction is added to the chain. So since this transaction is added, it can be accessed by B. So basic for blockchain transaction working, very basic working in transaction type. Okay, so let's get to the basic ledger technology. So now in most of the shops we can see ledgers. So ledger technology means all business activities, all transactions, all money flow, all record ചെയ്യുന്ന ഒരു database പോലെ. So എല്ലാ മാർക്കറ്റിലും different ledgers ഉണ്ട്. So ഒരു മാർക്കറ്റിനെ കൺസിഡർ ചെയ്യുമ്പോൾ you can see a lot of ledgers. So ഈ multiple ledgers ന്റെ concept നമ്മൾ eradicate ചെയ്യാൻ വേണ്ടിയാണ് blockchain as one virtual ledger considered. So blockchain എന്ന് പറഞ്ഞാൽ ഒരു നെറ്റ്വർക്കിൽ ഒരു specific ledger മാത്രമേ കാണാൻ പറ്റൂ. So this ledger tracks all types of transactions and all types of blocks in the chain. So okay. So it is protected through cryptographic encryption and distributed validation. You can see that. So basically, blockchain ledger working in chronological. That is, every transaction through timestamp. So since every set of transactions or every particular transactions act with a particular time line. So our time stamp create ഓരോ ട്രാൻസാക്ഷൻസും സ്റ്റോർ ചെയ്യുന്നത്. സോ ഈ കോൺസെപ്റ്റ് വരുമ്പോൾ നമുക്ക് ഈ സെൻട്രലൈസേഷൻ എന്ന കോൺസെപ്റ്റ്, അതായത് ഒരു സെൻട്രൽ അതോറിറ്റി എല്ലാം കൺട്രോൾ ചെയ്യുന്ന ഒരു കോൺസെപ്റ്റ് അവിടെ ഐഡന്റിഫൈ ചെയ്യാം. സോ എവരിവൺ ക്യാൻ വെരിഫൈ എ ട്രാൻസാക്ഷൻ. ബ്ലോക്ക് ചെയിനിലുള്ള എല്ലാ നോഡ്സും വാലിഡേറ്റേഴ്സ് ഒരു ട്രാൻസാക്ഷൻ ഇനിഷ്യേറ്റ് ചെയ്ത് കഴിഞ്ഞാൽ അത് വാലിഡേറ്റ് ചെയ്യും. So the next thing is public and private key. In public and private keys, it will be basic hashes. So this could be randomly generated large number. So public key it's a globally accepted, globally available hashing key. So it is generated from the private key. Okay. So എല്ലാവരും cryptocurrencies Bitcoin concept ആയി. So ആ കോൺസെപ്റ്റിനെ ഡിറൈവ് ചെയ്തേക്കുന്ന ബേസിക് കോൺസെപ്റ്റ് എന്ന് പറയുന്നത് ബ്ലോക്ക് ചെയിൻസ് ആണ്. സോ ബ്ലോക്ക് ചെയിൻസ് എന്ന് പറയുന്നത് ബേസിക്കലി ഡിസ്ട്രിബ്യൂട്ടഡ് ലെഡ്ജേഴ്സ് ആണ്. സോ ബേസിക് ലെഡ്ജർ ടെക്നോളജീസിനെ സിംഗിൾ ലെഡ്ജർ ആക്കി ഡിസ്ട്രിബ്യൂട്ട് നെറ്റ്വർക്ക് ത്രൂ ദ നെറ്റ്വർക്ക് ഡിസ്ട്രിബ്യൂട്ട് ചെയ്യാൻ പോകുന്നതാണ് ഡിസ്ട്രിബ്യൂട്ടഡ് ലെഡ്ജർ ടെക്നോളജി, അതായത് ബ്ലോക്ക് ചെയിനിൽ റൺ ചെയ്യും. Okay. So next thing, note the next point is miners are. So what are miners? So miners are the individuals who maintain and update the blockchain. അതായത് ബ്ലോക്ക് ചെയിനിൽ ട്രാൻസാക്ഷൻസ് ക്രിയേറ്റ് ചെയ്യുമ്പോൾ ബ്ലോക്കിലേക്ക് റൈറ്റ് ചെയ്യുന്നു എന്നുള്ളൊരു ആക്ഷൻ അത് ചെയ്യുന്നത് മൈനേഴ്സ് ആണ്. സോ ആ മൈനേഴ്സിനുള്ള റിവാർഡ് എന്ന് പറയുന്നത് every miner after completing a valid transaction would be given an amount of 12.5 bitcoins. So എങ്ങനെയാണ് മൈനേഴ്സ് ട്രാൻസാക്ഷൻസ് പ്രോസസ് ചെയ്യുന്നത്? So transactions എന്ന് പറഞ്ഞാൽ basically they are encrypted in SHA-256. So let's take a look at SHA-256. ഈ SHA-256 എന്ന് പറയുന്നത് ഒരു ഹാഷിംഗ് ടെക്നോളജിയാണ്. സോ ഇഫ് യു ഹാവ് എ സ്പെസിഫിക് ഫംഗ്ഷൻ ഓർ എ സ്പെസിഫിക് ടെക്സ്റ്റ് കോൾഡ് SANIA, it would be represented in SHA-256 or SHA-512 as this. So in case all of the letters in SANIA are caps, so you will get a completely entirely different hash output. So that is how. So consider ഒരു PDF file. A PDF file, you have a specific PDF file and another PDF file. രണ്ടാമത്തെ PDF file is similar to the first PDF file, but ഒരു letter, ഒരു single letter is misplaced. So ഈ രണ്ട് PDF file SHA-256 അതായത് hash output entirely different ആണ്. So അങ്ങനെ ഒരു ഹാഷിംഗ് അൽഗോരിതംസിന്റെ കംപ്ലീഷനിലാണ് ഈ ടെക്നോളജി ഫുൾ പ്രൊട്ടക്റ്റഡ് ആണ്. നെറ്റ്വർക്ക് ഉണ്ടോ? നെറ്റ്വർക്ക് ഉണ്ടോ? ഞാൻ Okay, so the SHA-256 പോലുള്ള algorithms നമുക്ക് ഓൺലൈൻ തന്നെ ചെക്ക് ചെയ്യണമെങ്കിൽ you can go and just type SHA-256 online and you will be redirected to the first. You can just click the first link and you will get this converter. So consider you have a specific input called SANIA. So this is the hash output you will get. So if you have some mobile phones or something, you can check it whenever you have the time. So this is the output we get while typing SANIA like this. So you can see that it changes entirely when a single alphanumeric bit is changed. So every time a change occurs, it is hashed in a different value. So that is the security aspect of hashing technology. Okay, so this is the basic architecture of a blockchain. So there are many blocks in this blockchain. So each block contains transaction. So the first blocks, when the first transaction occurs, you create a first block. Every other block is linked from this block. അതായത് first ഒരു genesis block എന്ന് പറഞ്ഞാൽ you can write that down. The first block which is created in the transaction process is called genesis block. GENESIS block. So each block second block influence here. So since each are connected, each blocks area connected. So which means that there is a chain link. ഈ ചെയിൻ സ്പ്ലിറ്റിംഗ് എന്ന് പറയുന്നത് ഇറ്റ്സ് കോൾഡ് പ്രീവിയസ് ഹാഷ്. അതായത് ഹാഷ് വാല്യൂസ് വെച്ചാണ് ബ്ലോക്സ് ഡിഫറെന്റ് ബ്ലോക്സ് ലിങ്ക് ചെയ്ത് പോകുന്നത്. Okay. Then we can look into the different types of blockchain. There are two types: public blockchain and private blockchain. There is also another type called consortium blockchain. We will not look into this right now, but have you been introduced to Ethereum? Okay. So, what is the difference between Ethereum and private blockchain?
There's no direct blockchain.
Excuse me.
There's no direct blockchain.
Okay. So the basic difference is public and private. So in case of Ethereum, every users are treated equally. This means that there is a certain currency called you can check while doing smart contracts in Ethereum. It's called Ether. Ether is the basic currency that runs in Ethereum network. So that's why it's called Bitcoin is a single coin. There is a Bitcoin and it's called Ethereum. Have you tried testing the faucet and MetaMask or something? No. Yeah. So the next day we'll be talking about blockchain, wallet, and Ethereum. So we'll get to that. There is a so if you type metamask.io, it is written that it brings Ethereum to your browser. Metamask.io is nothing but an Ethereum wallet. It stores your Ethereum. So if you have 5 Ethereums in your wallet, it will be reflected in the MetaMask account. So metamask.io is something you will be familiar in the coming days. Okay, so that's what I could tell you right now about public blockchain. So let's get to private blockchain. Hyperledger is a private blockchain. As the name suggests, it is private. So many functionalities of it can be controlled. That is why Hyperledger and Sawtooth, Fabric, etc. are being used in basic in commercial users. So in a specific company, if you want to control the viewability of blocks and all, you could use Hyperledger. That is, transactions can be secret, members of the network can be known. In case of Ethereum, a public blockchain, users' data are not visible. It would be basically your ID and your account or your wallet would be just such a physics hash. So you would be identified by a single hash. But in private blockchain, you could control how you can view the users and certain links of the blockchain. So they are called validators. You would be familiar with it after a while. So this is the identity management part. In public blockchains, it's anonymous, and in private blockchain, it is not. So most businesses use private permission blockchain. So they can know who they are dealing with. The members of the blockchain can use it. Okay. So this is the concept that proves the usability of a blockchain network. Consider everyone or every validator on the network. Everyone is building that 91th block of the blockchain. So somebody wants to alter this 74 blocks. So if a hacker wants to add this 74th block, he has to change 75, 76, 77 up to 91th block. And he has to do that before the 91th block is completed by all the validators of the network. So simply, നമ്മൾ explain ചെയ്യുകയാണെങ്കിൽ ഒരു സിംഗിൾ ബ്ലോക്ക് ഒരു 91th ബ്ലോക്കിലാണ് ഇപ്പൊ എല്ലാവരും വർക്ക് ചെയ്തുകൊണ്ടിരിക്കുന്നത്. If you want to access or change the data in a transaction in a lower block, say 74, അതിന് മുമ്പ് അത് കഴിഞ്ഞ് വരുന്ന ബ്ലോക്സ് എല്ലാം അതിലെ ഹാഷസ് വെച്ച് ലിങ്ക്ഡ് ആയിരിക്കും. സോ ഈ ഡാറ്റ ഓൾട്ടർ ചെയ്ത് അപ് ടു 91 വരെ നമുക്ക് ഓൾട്ടർ ചെയ്ത് പോയാലാണ് ഒരു സിംഗിൾ ഓൾട്ടറേഷൻ നടക്കാൻ പറ്റും. സോ ഈ ബ്ലോക്ക് ചെയിൻ നെറ്റ്വർക്കിന്റെ പ്ലസ് പോയിന്റ് അതാണ്. സോ ഒരു ബ്ലോക്കിലെ ഡാറ്റ ഓൾട്ടർ ചെയ്ത് we have to have certain GPU requirements, അതുപോലെ SHA-256 അങ്ങനെ പല capabilities നമുക്ക് ആവശ്യമുണ്ട്. So it uses a lot of resource. So അതുകൊണ്ടാണ് it is not worthwhile to hack the blockchain. So we can discuss the four main factors or four main characteristics of the blockchain. It is replicated ledger. That a single ledger ഉണ്ടാവും. ഈ സിംഗിൾ ലെഡ്ജർ നമ്മൾ ഡിസ്ട്രിബ്യൂട്ട് ചെയ്ത് കോപ്പീസ് ഓരോ ആൾക്കാരുടെ കയ്യിൽ കൊടുക്കും. So it creates a link and everyone is aware of the transaction. And it's happened only with immutable pass means that each block നമ്മൾ ജെനസിസ് ബ്ലോക്കിനെ കുറിച്ച് സംസാരിച്ചു. ആ ജെനസിസ് ബ്ലോക്ക് ആണ് നെക്സ്റ്റ് ബ്ലോക്കിലേക്കുള്ള കണക്ഷൻ ക്രിയേറ്റ് ചെയ്യുന്നത്. സോ ഈ പാസ്റ്റിലുള്ള ബ്ലോക്സ് ആയിട്ട് കണക്ട് ചെയ്യുന്ന ഓരോ ബ്ലോക്സും ക്രിയേറ്റ് ചെയ്ത് പോകണം. സോ അതുകൊണ്ടാണ് ഇമ്മ്യൂട്ടബിൾ പാസ്റ്റ് ആയിട്ട് അപ്ലൈ ചെയ്ത് പോകുന്നത്. And it's distributed and replicated, that we know. And the next thing is cryptography. Cryptography ഒരു മെയിൻ കൺസെപ്റ്റ് ആണ്. ക്രിപ്റ്റോഗ്രഫി എന്ന് പറയുമ്പോൾ തന്നെ അതിൽ ഒരു പ്രൈവറ്റൈസേഷൻ ഒരു പബ്ലിക്കലി അവൈലബിൾ അല്ലാത്ത ഒരു കോൺസെപ്റ്റ് വരുന്നു. സോ ഇറ്റ് ഇൻക്രീസസ് ദ ഇന്റഗ്രിറ്റി ഓഫ് ദ ലെഡ്ജർ ആൻഡ് ഒതന്റിസിറ്റി ഓഫ് ട്രാൻസാക്ഷൻസ്. സോ എല്ലാ ട്രാൻസാക്ഷൻസും ഹാഷ്ഡ് ആണ്. സോ ഇതിൽ നിന്ന് ആർക്കും ഡാറ്റ ആക്സസ് ചെയ്യാം. ഇറ്റ് ഈസ് നോട്ട് വർത്ത് ആക്സസ് ചെയ്യാൻ പറ്റില്ല എന്നല്ല, അത് അവരുടെ ഹൈ GPU പവറും അതുപോലെ അവർക്ക് അതിൽ ഇൻവെസ്റ്റ് ചെയ്യേണ്ട റിസോഴ്സസ് ഒക്കെ വെച്ച് നോക്കുമ്പോൾ ആരും ചെയ്യില്ല. ബിക്കോസ് ഇറ്റ് ഈസ് നോട്ട് വർത്ത്. സോ ഐഡന്റിറ്റി ഓഫ് പാർട്ടിസിപ്പൻസ്, അതായത് ഈച്ച് വാലിഡേറ്റേഴ്സിന്റെ ഐഡന്റിറ്റി സീക്രട്ട് ആയിരിക്കും. പിന്നെ നെക്സ്റ്റ് തിങ് ഈസ് കോൺസെൻസസ്. കോൺസെൻസസ് എന്ന് വെച്ചാൽ ബേസിക്കലി ഇഫ് യു സെർച്ച് ദ മീനിങ് ഓഫ് കോൺസെൻസസ്, okay, you can see it is basically a general it is basically a general agreement. The consensus is basically an agreement. ഈ agreement ആര് തമ്മിലാണെന്ന് വെച്ചാൽ validators of nodes of the network. അതായത് ആര് വാലിഡേറ്റ് ചെയ്യുന്ന ഉള്ള ഒരു ജനറൽ അഗ്രിമെന്റിനെയാണ് കോൺസെൻസസ് നമ്മൾ ഡിഫൈൻ ചെയ്യുന്നത്. Okay, it is a decentralized protocol. അതായത് ഒരു ജനറൽ അഗ്രിമെന്റിനാണ് നമ്മൾ കോൺസെൻസസ് എന്ന് വിളിക്കുന്നത്. ഈ കോൺസെൻസസ് നമുക്ക് തന്നെ ഡിഫൈൻ ചെയ്യാവുന്നതും സിസ്റ്റം തന്നെ ഡിഫൈൻ ചെയ്ത് വെച്ചിരിക്കുന്നുണ്ട്. ഈ ഫോർ എക്സാമ്പിൾ ഹൈപ്പർ ലെഡ്ജറിൽ പ്ലഗബിൾ കോൺസെൻസസ് എന്ന് പറഞ്ഞൊരു സ്പെസിഫിക് ക്രൈറ്റീരിയ ഉണ്ട്. അത് നമുക്ക് തന്നെ ഡിഫൈൻ ചെയ്ത് കോൺസെൻസസ് എങ്ങനെ വാലിഡേറ്റേഴ്സ് വാലിഡേറ്റ് ചെയ്യണമെന്ന് നമുക്ക് തന്നെ ഡിഫൈൻ ചെയ്ത് വരും. So next thing is business logic. Smart contracts എന്താണെന്ന് everyone would be aware, right? Okay. So smart contracts എന്ന് പറയുന്നത് basically എത്തീരിയത്തിലേക്ക് എടുക്കുമ്പോൾ everyone would be aware of that. So smart contracts ആണ് basic business logic ആണ്. അതായത് എങ്ങനെ ട്രാൻസാക്ഷൻസ് നടക്കണം, ആര് തമ്മിൽ നടക്കണം എന്നൊക്കെയുള്ള ഒരു ബിസിനസ് ലോജിക്. So our business logic വെച്ചാണ് നമ്മൾ decentralized applications derive ചെയ്യുന്നത്. So it is a basic logic embedded in the ledger. അതായത് ലെഡ്ജറിൽ ഓരോ ട്രാൻസാക്ഷൻസ് എങ്ങനെ നടക്കുന്നു, ആര് തമ്മിൽ നടക്കുന്നു എന്നൊക്കെ സ്റ്റോർ ചെയ്യുന്ന ഒരു സ്പെസിഫിക് ലോജിക് ആണ്. Okay, so these are the basic applications of blockchain. First is in logistics. So supply chain ഓരോ പോയിന്റിലും നമുക്ക് അത് ഒരു ഡാറ്റ റെക്കോർഡ്സ് ആയിട്ട് വെക്കാമെങ്കിൽ it would be really helpful in logistics. അതായത് ഓരോ from a single starting product to end product ഓരോ ട്രാൻസാക്ഷൻസ് നമ്മൾ റെക്കോർഡ് ചെയ്ത് വെച്ചാൽ ലോജിസ്റ്റിക്സിൽ അത് വളരെ ഹെൽപ്ഫുൾ ആണ്. സോ ലോജിസ്റ്റിക്സിൽ ഒരു ബേസിക് കോംപ്ലക്സ് ട്രാൻസാക്ഷൻസ് സിംപ്ലിഫൈ ചെയ്യാൻ ബ്ലോക്ക് ചെയിൻ യൂസ് ചെയ്യും. അതുപോലെ തന്നെ പ്രോപ്പർട്ടി റെക്കോർഡ്സ്. സോ ഇഫ് സമ്മൺ ബൈസ് എ ലാൻഡ് ഇൻ 1950 1950 ബ്ലോക്ക് ചെയിൻ എന്ന് പറഞ്ഞ കോൺസെപ്റ്റ് ആലോചിച്ചിട്ടും കൂടി ഉണ്ടാവില്ല. ബട്ട് 1950 ഒരു ലാൻഡ് ട്രാൻസാക്ഷൻ നടന്നു. So our transaction blocks record you could access that data in the final end of the chain in 2019 or 2020. So this data is saved and entered in the ledger itself. So other the property records basic databases in safe file blockchain story. And the next thing is capital market. So ഇതുപോലുള്ള ട്രാൻസാക്ഷൻസ് റെക്കോർഡ് ചെയ്യുന്നുണ്ട്. നമുക്ക് സെറ്റിൽമെന്റ് ടൈംസ് ആവശ്യമുണ്ട്. അതായത് ഈ ഡിസ്പ്യൂട്ട്സ് ഫോർ എക്സാമ്പിൾ നമ്മുടെ ലാൻഡിന്റെ എക്സാമ്പിൾ പറഞ്ഞു. അതിൽ ലാൻഡ് ഡിസ്പ്യൂട്ട്സ് ഒഴിവാക്കാൻ ഈ ഡാറ്റ ഈ എൻക്രിപ്റ്റഡ് data that nobody can edit, it would be really helpful in capital markets. So due to transparency and verifiability. So എല്ലാ നോട്ട്സിന്റെ നെറ്റ്വർക്സും വെരിഫൈ ചെയ്യുന്നുണ്ട്. ട്രാൻസ്പെറൻസി എന്ന് നമ്മളൊരു കോൺസെപ്റ്റ് അവിടെ നമ്മൾ ഡിഫൈൻ ചെയ്യണം. ഓക്കെ, സോ ഇത് നോക്കണ്ട. വി ക്യാൻ ജസ്റ്റ് ലുക്ക് ഇൻടു നാക്കമോട്ടോ. സത്തോഷി നാക്കമോട്ടോ എന്ന് പറഞ്ഞ ഒരു ഗ്രൂപ്പ് ഓഫ് പീപ്പിൾ ആണ് ബ്ലോക്ക് ചെയിൻ കോൺസെപ്റ്റ് അല്ലെങ്കിൽ ബിറ്റ്കോയിൻ കോൺസെപ്റ്റ് ഇൻട്രൊഡ്യൂസ് ചെയ്തിട്ടുള്ളത്. സോ അവര് അതിൽ ഡിഫൈൻ ചെയ്തിരുന്ന കോൺസെൻസസ് ആണ് നാക്കമോട്ടോ കോൺസെൻസസ്. So it is basically a lottery race. So we have 5 validators. ഒരു നെറ്റ്വർക്കിൽ 5 validators ഉണ്ട്. ഈ 5 validators they have to reach an agreement or they have to reach a consensus. Are they validating? So it is checked by a lottery race. So lottery race is not everybody is given. അതായത് എല്ലാവരും ഒരു ഹാർഡ് പസിൽ സോൾവ് ചെയ്യണം. So who for example for 5 validators 5 പേരും ഒരു ഹാർഡ് പസിൽ അസൈൻ ചെയ്തു. സോ ഈ പസിൽ എല്ലാവരും സോൾവ് ചെയ്യും. ഒരു 90% ആൾക്കാർ സോൾവ് ചെയ്യും, 10% സോൾവ് ചെയ്യും. സോ ഈ 90% സോൾവ് ചെയ്ത ആൾക്കാരിന് റാൻഡംലി ഒരാളെ സെലക്ട് ചെയ്യും. സോ ഇറ്റ്സ് ബേസിക്കലി ലക്ക്. സോ അതുപോലെ ഒരു ലോട്ടറി റേസ് കൺസെൻസസ് ആണ് നാക്കമോട്ടോ സത്തോഷി നാക്കമോട്ടോ ഫസ്റ്റ് ഡിഫൈൻ ചെയ്തത്. So basically proof of work enna concept. Different concepts of consensus ഉണ്ട്. അത് first proof of work, proof of elapsed time. You could note it down ഞാൻ ഹൈപ്പർലെഡ്ജറിലേക്ക് ഇറക്കുമ്പോൾ പറയാം. Proof of work. Proof of work consensus. ഇതില് നമ്മൾ നേരത്തെ പറഞ്ഞ ലോട്ടറി മെക്കാനിസത്തിൽ ഒരു സ്പെസിഫിക് വർക്ക് അസൈൻ ചെയ്തു. ആ വർക്ക് സോൾവ് ചെയ്യുന്നതിനനുസരിച്ച് വാലിഡേറ്റേഴ്സിനെ സെലക്ട് ചെയ്യുന്ന കോൺസെൻസസ് ആണ് പ്രൂഫ് ഓഫ് വർക്ക് കോൺസെൻസസ്. നെക്സ്റ്റ് ഈസ് പോയറ്റ് കോൺസെൻസസ്. Okay, next is proof of elapsed time അല്ലെങ്കിൽ പോയറ്റ് കൺസെൻസസ് എന്ന് പറയുന്നത്. ഈ consensus sector basically എന്താ എന്ന് we will learn when we get to hyperledger. And the next thing is Byzantine fault tolerance or practical Byzantine fault tolerance. Fault tolerance, when we define it, it means that the ability to withstand faults, that is, ability to make less faults. So, അങ്ങനെ ഒരു voting mechanism ആണ് Byzantine fault tolerance അല്ലെങ്കിൽ PBFT, practical Byzantine fault tolerance definition. Okay. So that is the basic consensus which we use commonly in hyperledger. Byzantine fault tolerance again. Okay. So you would check that later. So hashing it is converting to a specific form. That is, they take an electronic record and produce a fixed length output. So, for example, PDF it creates a text or alphanumeric output which is corresponding to that particular input. So, if an information is changed in any way, even a comma is changed in a 3,000 page document, a different output value is produced. So, a 3,000 page document, just a single change or uppercase letter, lowercase letter, I don't know type data. It would produce a different hash. Okay. So, hashes create transactions like record process data 1, data 2, data 3, and data 4. All hashed values are. The hashed values combine transactions like sending. The transactions are like blocks. You can see something called previous hash. This previous hash is the main linking factor between the blocks. This previous hash is different blocks linked. Okay. Now let's get into Bitcoin. This blockchain concept derived first type of electronic currency are Bitcoin. So it is the secure digital currency. So let's look into the advantage of physical and online cash. So physical cash is basically non-traceable. Most of it cannot be traced. So most of it is only secure and it is prone to low inflation. So the next thing is the problem of centralization. The central bank, that means the bank can see all your transactions. So there is a central authority. So we have to trust that particular central authority when we do our transactions. So in case of eCash, we can see that it is secure, single use, reliable, and privacy preserved. So in blockchain and Bitcoin concept, there is no need for a central authority. We do not have to disclose the details to a particular bank while we are doing a particular transaction. And every validator or every node in the network has access to this complete data. Okay. So it is a distributed, decentralized digital currency system. It is released by Satoshi Nakamoto in 2008. So he released the white paper describing the complete techniques, and it was adopted as a Bitcoin, a new currency system. So it is effectively a bank run by a network. That is a bank which has no centralization, which is completely decentralized. So the checks or the money is completely digital and it is completely distributed throughout the globe. Which means that you can use, if blockchain is completely deployed all over the world, you can use Bitcoins here with the same value as it is in Estonia or any other place. Actually, Estonia is where the complete legal system is converted into blockchain level. So they have Bitcoin networks for every kind of transaction and every type of government databases are stored in blockchain. So Estonia is completely Bitcoin and blockchain oriented place. Okay, so this is the size of the Bitcoin economy. So there was a number of Bitcoins in circulation, about 11.8 million in December 2030. So it has now risen to 18 billion. But there is a number in the maximum amount of Bitcoins that can be generated. So it cannot exceed 21 billion. So you know that for a Bitcoin to be valid, you have to have certain hashes. So the easier hashes are done. So the remaining thing is the non-easier, right? I mean the hard hashes. So that's why it cannot exceed 21 million. And to reach 21 million, it would take a time of about 52 years. So from 18 to 21, it could be a slow rate. You can see about 11.8 million to 18 million. It took about 8 to 9. It took about 6 to 7 years. So, okay. So the speed is 30 transactions per minute. As compared to Visa transactions, it's really slow, but there is no centralization, there is no extra charges. So that is why. Okay. So if you take a look at the back page of the paper, you can see how a Bitcoin transaction works. So the first thing is wallets and addresses. Okay, so consider I showed you about MetaMask, right? So that is a basic wallet. It is similar to your digital wallets, but it stores Bitcoin or in this case Ethereum. So consider Bob is a vendor and Alice is a sender. So Alice wants to send a particular number of bitcoins to Bob. So Bob has to create a wallet. So you can see that Bob uses his computer to log in and create a wallet. A wallet is a storage for addresses. These addresses permit the storage of Bitcoin. Okay, so if Alice wants to send a particular number of bitcoins to Bob, Bob has to create a wallet to receive it. So that's what you see this empty address here. So okay, he creates a new address in the wallet to store the Bitcoin. So the next point is submitting a payment. So Alice sends this payment to Bob. So Alice, she has this filled wallet right here. So she's sending this to Bob, who has an empty address or an empty wallet. So she sends this transaction, this Bitcoin to here. So when it is sent, it is going through specific encryption. Basically, such a FIDO landmark. So this sending of Bitcoin or this particular transaction is encrypted. That is what is done here. So ഇവിടെ encryption നടന്നു mining process related. In mining process, you see these three people there, the miners. So they validate and they create the blocks and create the transaction. So this particular transaction from Alice to Bob is stored into the transaction by the miners and they get a reward for that. Okay, so miners they use really power consuming and resource consuming algorithms. So they have specific computers which have nodes which have these programming and these processing capabilities. So after that, after this transaction is created, another block is created from here. So these blocks are linked together into specific chains. There are certain processes, you can read those cryptographic processes which are working beside that. And after the creation of these blocks are linked. After the creation of the first block or Genesis block, this linking occurs. Okay. So each block is linked to each block is linked to the next using previous hashes. So after that, a blockchain network is created. Okay. After the creation of these blocks are sent to validation. So it is sent to every node of the network. So if we have created a specific blockchain network for the market which Bob is in, so every person or every validator in the market gets a copy of this ledger. So everyone validates, and finally a transaction is approved. So after the transaction is approved, the process continues and new blocks are created to the chain. So as far as transaction goes, every transaction creates a new entry or a new block in the ledger, which is copied to everyone on the network. So everyone has a chance to validate, and everyone has a copy of the ledger. So that's how a basic Bitcoin transaction works. There are certain steps that you could read. They are the extension of what I said. So this could be your currency. Okay. So these are the different currencies in the network. We can see new shares, blue coins, Dogo coins, Litecoins, Bitcoin. It's the most famous one, and Nucoin, Monero, Capricorn, like that. There are a lot of blockchain networks which has the different cryptocurrencies. So each has different values, but Bitcoin is the most important and most significant one on the market. Also, Ethereum is also important because mainly for deploying of smart contract. If you want to deploy a smart contract in Ethereum, depending on the program you have, depending on the file or program file you created, it has something called specific gas or specific day value. So you need a bit of Ethereum for the program to run. So let's get to Hyperledger solving. So before we get into that, we could look into the applications.
Welcome to the Hyperledger Greenhouse, an open source consortium for developing business blockchain technologies hosted by the Linux Foundation. Within the Greenhouse, diverse global communities collaboratively develop open source projects that uniquely approach enterprise blockchain challenges. These technologies can cross-pollinate and interoperate, just like how the communities driving the projects collaborate in an open and neutral environment. Built from the ground up for enterprise use, the Hyperledger Sawtooth design philosophy targets development of decentralized ledgers and secure, scalable smart contracts. The Sawtooth security model uses a single node type, which simplifies deployment. Plenty of examples exist for both on-prem and cloud installations. On-chain governance lets enterprises manage all aspects of the Sawtooth network with the network itself. Participants set policies and agree on configuration changes using sawtooth transactions. In fact, even consensus algorithms can be changed real time in a running network. Start with RAP, then partner with PDFT, or switch to proof of the last time as the network grows. Sawtooth software development kits cover a wide variety of languages. The smart contract model supports deploying any and all of these languages alongside each other. Ethereum contracts, for example, can be deployed alongside WebAssembly and Java contracts. Sawtooth distributed ledger technology can integrate with existing internal databases by keeping internal relational and key-value databases in sync with the Sawtooth network. Whether you are using Sawtooth for healthcare, supply chain, or financial services, your internal systems can make use of all the data managed on the Sawtooth blockchain. Get started with Hyperledger Sawtooth today by downloading the source code, accessing the documentation, and joining our community from our website.
Okay, so this is the basic official video from the Hyperledger Sawtooth community. They say that they have a greenhouse, that they have a community which inhibits or which grows the program in their specific environment. So if you have a specific program, they have a community which will help you to grow different smart contracts and different consensus algorithms so that you can create your diverse application. So these are the basic Hyperledger projects. So we would be discussing mainly about Sawtooth. The other projects are Hyperledger Fabric, Inti, Iroha, and Burrow. These different, all of the Hyperledger products or projects are basically private blockchain, but they are used in different types of applications. That is why we have these different types. So we would take a look at Sawtooth. Okay. So let's see what Sawtooth is. Sawtooth is basically an enterprise blockchain platform for distributed ledger. So when we talk about enterprise, we talk about big companies and smaller companies which use permission networks. So each company has a network. Even here we have a permission network for Wi-Fi access. So like that, every enterprise needs a permission network. So this Sawtooth, Hyperledger Sawtooth is an enterprise blockchain platform for distributed ledger. So it is used to create distributed ledger applications and distributed networks. Okay. So it has a modular architecture, and there is a certain separation between different parts of the network. So we will discuss about that as soon as we get into it. So the key components, this you have to know about, is basically for Sawtooth and basically for most of the Hyperledger application, you have a client. Client is the interactive side of the program. As we know, in basic program, we have a client side and we have a server side. This is not basically different from our basic client side, but this client initiates transaction. This is where we create transactions. And the next thing is validator or validator network. Validators are the basic nodes of the network. You and I can be validators of the specific blockchain network. And the next thing is transaction processor. It is an entirely different part of the system. It is used to process the incoming transactions. So if we send a specific transaction using the client, we can process it using the transaction processor. And the next thing, state and blocks. State is almost like a database. It stores the basic state or the number and type of transactions that occur in a Sawtooth network. And the final thing is consensus. Consensus, we will discuss about it. Consensus means basically an agreement in which different validators select their validating style. So this is the basic architecture of permission blockchains or Hyperledger Sawtooth for this instance. So we can see that a client communicates to a validator through a REST API. So this is where transactions are initiated. So every transaction is sent to a validator. So the validator forms a link between the transaction processor and the client. That is an important concept. Validator is a linking factor between clients and transaction processor. So it contains the consensus, state, etc. These are the basic nodes of the system. Okay, and this validator creates another set of validators for a network, and that creates the complete sawtooth network. Okay. So let's get to know about client. What is a client? Client is any system that can initiate a transaction. It could be a web browser, GUI, CLI, backend server, etc. So this client needs to connect to a validator. So validator, as we know, is the linking chain between processor and client. So client needs a connection to the validator. So it submits transaction request. Every time a transaction is initiated, it sends a request to the validator. So this request is processed by the request is received in the validator and is sent to transaction processor. Okay. Okay. It has the ability to send queries to receive the state. State is nothing but a storage. It stores the transaction details. So if you want to receive the particular state, if you want to know which transactions happen and what kind of transactions happen, we want to call the state. So we submit it through the client. Okay, so all of us are aware about transaction. So to create a block, we group a bunch of transactions together and we call them batches. Batches are nothing but a collection of transactions which are put in a block. So I guess, okay. Okay, I don't have that. Okay, so consider this as a single block. So in this block, we have received a bunch of transactions. Transaction 1, etc. up to transaction n. So we group it together as a batch and we give it a specific timestamp. Similar to this, we have another batch with a different timestamp. So, ഓരോ ടൈമിലും റിസീവ് ചെയ്യണ സെറ്റ് ഓഫ് ട്രാൻസാക്ഷൻസിൽ ഓരോ ടൈം സ്റ്റാമ്പ് ഇട്ട് നമ്മൾ ഗ്രൂപ്പ് ഓഫ് ട്രാൻസാക്ഷൻസ് ഗ്രൂപ്പ് ചെയ്ത് ഒരു ബാച്ച് ക്രിയേറ്റ് ചെയ്യും. സോ ഇങ്ങനത്തെ ബാച്ചസ് നമ്മൾ കാസ്കേഡ് ചെയ്താണ് ഓരോ ബ്ലോക്സും ക്രിയേറ്റ് ചെയ്യുന്നത്. So that's what is said here. Batch contains one or more transactions that are committed or discarded together. So that is what a client sends to the node or the validator. Okay. So next thing is validator. Validator is the basic node in a sawtooth network. So every person in a hyperledger or a blockchain network is a validator or a node. So validator, as the name suggests, needs to validate a single transaction or a group of transactions that are going on in the network. Okay. So in Sawtooth, we give all validators block publishing permissions. That is, every validator has the permission to publish a block. So since it is public in nature, private in nature, we have the privilege to provide all blocks, all validators as block publishing publishers. So transaction processes connects to the validator. We know that validator connects the DP and the client. So let us look at a basic example. And before that, we could look. Okay, we will look into an example which shows the basic Hello World Sawtooth program. So before that, let's look into transaction processor also. Okay. So every validator maintains a complete copy of the transaction history in the blockchain. So as I said, in a distributed ledger, everyone has a copy of the transaction list, or everyone has a copy of the ledger. So these validators have a copy of the transaction history. So also, as I said, there is something called state. State shows the types and amount of transaction that occur. It's similar to a database. So validator has a copy of that also. So since it is a basic node, it has to have all those copies. So then it participates in the consensus mechanism. So consensus mechanism means the mechanism by which we select a type of validator to validate the specific block. Okay. The next thing is transaction processor. Transaction processor is the program that executes transactions sent by client. So a client sends a specific request or a transaction process request. So it is a request to process the given transaction. So transaction processor processes or executes these transactions by the client. So this is where you write your business logic. So before I bore you with the further details, let's look into a small example. So while you are creating a application, specific application, it's called Hello World. So you have to create a client and a processor. Okay. This is the Hello World client that I have written. It is the client side of the application, and this is the Hello World processor. These two things are important while you are creating a Hyperledger based application.
You use your benefit. What is the application?
This is basically a Hello World application. Sawtooth. Yeah, Hyperledger Sawtooth. So we are talking about Hyperledger Sawtooth. So it has client side and a processor side. So I think you can see right here or right here. It has a client side. In the client side, okay, in the client side, we have something that is similar to an Express application. What we do using a Node.js or Express application. Can't see that. Okay. In the focus on adjust the can you see it now?
Yeah.
So we have client side. I have opened the client side, and you can see a similarity with basic Node.js based or basic Express based application. So we use basic Express requirements and all. So in this, we write the client side logic. So this is how transaction. This is where we write where transactions are to be sent. And we have another side. It's called a processor. It's I have given it hello world processor. Okay. So inside that we have a handler and a processor. So okay, handler is where you do your device hashing. Before that, if we want to send a specific message to the processor through the client, first we call this client part. In the client part, I have encoded a message and I have sent it to the validator. The validator routes it to the processor side. So in the processor side, what we do is we decode what we encode. So it's called payload. So we send a particular set of data, encoded data to there, and we decode it in the hello world processor here. So in hello world processor, you can see that we have handler. It handles the transactions that we have sent through the client side. So when we get to the hands-on part, we would get a basic idea of how we do this. So let's not focus about it. This is just to show you. Yes. Hyperledger Auto is a free community. It has a specific we have a specific community in Hyperledger to deploy apps. So you just have to have a specific requirement. So I would tell you the requirements after this. Okay. 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 So transaction processor is a basic program that executes a transaction sent by client. I have told you we send encoded bytes through the client and we process it through the processor. So after the processed data, we in case we have to do something with it, we code that in the transaction processor. So this is where the application business logic resides. This determines what we do with the transactions that we have received. So this is not related to the blockchain. It is a different entity from the blockchain. Transaction processor is a specific program for decoding and working on the transactions that you have received. So it is an off-chain, but it is connected to the validator. So okay. Okay. The next thing is state and block. State is a unit of storage. It stores the data structure of the blockchain. The data structure of the blockchain is nothing but the hashes of the blocks and transactions which are inside it. If we are doing a hands-on, I think in the final day, we would get to know about calling the state. So basically, a state is similar to a JSON file. JSON, everybody knows about JSON files, right? So it is similar to a JSON file, but each key value pair are transactions and blocks. So it is similar to the settings file we see. It is similar to the settings file we have. Okay, settings.json file we have. So state is also a separate entity, but it is related to the chain. So it is a registry of the transactions that has happened. So let's take an example of a banking application. So in this case, the blockchain would be similar to the transaction history of the bank. and every transaction would be an account transfer. So this is an analogous. This is an analogy to the basic transaction that we undergo when considering a bank. And the next thing is ledger state. Ledger state is our basic account balance or passbook record or something. Okay. This is something you need to know by programming. So every state is a collection of addresses. It is in a specific address. It is indexed by the defined byte address. So it is maintained by the validator. We can query it using a client pushing. If we push a certain request to using the client, we can see the state of the blockchain. So transaction processors can store and update states. Okay, nice. Next thing is consensus. Consensus is the basic agreement which decides the validation. So there are different types of consensus: dynamic consensus and pluggable consensus. So dynamic consensus is the agreement that we settle during running of a blockchain. So when we set up a blockchain network, we give it a certain agreement on how the validators can validate. That is a dynamic consensus. And also pluggable consensus is a consensus that we define using the sawtooth SDK. So those types of consensus we'll talk about in this part. Okay. So the first one is proof of elapsed time consensus. Proof of elapsed time is an important consensus in sawtooth network. So, for example, there are 5 to 6 validators in a network. So each validator is given a task and it is set to wait for a specific time. Now, ഓരോ വാലിഡേറ്റേഴ്സിനും ഒരു സെറ്റ് ഓഫ് ഒരു ടൈം ലിമിറ്റ് കൊടുക്കും. ആ ടൈം ലിമിറ്റിന് എന്നിട്ട് ഈ വാലിഡേറ്റേഴ്സ് വെയിറ്റ് ചെയ്യാൻ പറയും. So that's what happens. Each participating node in the network is required to wait for a randomly chosen time period. And the first one to complete the designated waiting time wins the new block. കുറച്ചു നേരം വെറുതെ ഇരിക്കാൻ പറയും. Basically, that's what happens. And ഈ task complete ചെയ്യണ validatorനെ basic validating permissions holds. So, okay. So each node in the blockchain network generates a random wait time and goes to sleep for that specific duration. The same thing. Okay. The next important consensus are developer mode consensus. It is used in basically developers and test networks. The next one is RAT. It is a crash fault tolerant, or when it is, if you have a certain number of validators in a network, you check each validator and see if it responds. So when a validator does not respond, it chooses another validator as the leader. So the next thing is PBFT, or practical Byzantine fault tolerance. This is also very important. There was a general named, there was a Byzantine general. He proposed this particular. Okay, no problem. It was proposed by the Byzantine general. It means that everyone is given a specific amount of work. So, as the name suggests, there is a specific fault tolerance. So, if you are given a specific work, it checks if you have a possibility to create a fault. So, if there are 5 to 6 validators in a network, it checks all the validators if they are producing a fault. So if the system or the node or the validator which produces the lesser number of fault is selected as the basic validator. Okay, so the basic features of Sawtooth, Hyperledger Sawtooth are on-chain learning. So, this means that if you are still inside the blockchain, you have the access to create new consensus and new algorithms that defines how validation and defines how block creation is to be done. So you have that kind of programming capability in Sawtooth. If you have already created a blockchain, you can access the consensus and you can change the consensus on runtime. That is what Sawtooth provides. And the next thing is clear segregation of application logic and core system. We have seen that. Okay, we have seen that transaction processor is entirely unrelated to the complete block. It checks the it processes the transaction from out of the block. So so that is why you have a segregation of application logic and core system. So the basic system or the basic blockchain is separated from the application logic. That means the transaction processor acts as a different entity from the blockchain. So that is what is said here of the transaction processor and a trusted execution environment. So in enterprise blockchain, we need a certain amount of trust. So in case of companies, ഓരോരുത്തർക്കും ഓരോ ഡിഫറെന്റ് പെർമിഷൻസ് ആയിരിക്കും. ചിലവർക്ക് വ്യൂയിങ് പെർമിഷൻസ് ഉണ്ടാവുള്ളൂ, ചിലവർക്ക് എഡിറ്റിംഗ് പെർമിഷൻസ് ഉണ്ടാവും. അതെല്ലാം ക്ലിയർലി ഡിഫൈൻ ചെയ്യാം. ആർക്കൊക്കെ ബ്ലോക്സ് വ്യൂ ചെയ്യാം, ആർക്കൊക്കെ ബ്ലോക്സ് ആക്സസ് ചെയ്യാം, എഡിറ്റ് ചെയ്യാം എന്നുള്ളതൊക്കെ നമ്മൾ അങ്ങനെ ഒരു ട്രസ്റ്റഡ് എക്സിക്യൂഷൻ എൻവയൺമെന്റ് ക്രിയേറ്റ് ചെയ്യും. And next thing is parallel transaction execution. This is a key concept. It means that we have a specific transaction which are working from A to B. So if there are 5 to 6 validators, if A sends a transaction to B, we can process that in one side, and if C sends another to D, we can process it in different time intervals. So that's how we parallelly execute transactions. So okay, the next thing is an event mechanism. We can call specific events to create transactions. And next thing, pluggable consensus algorithm. This means that during runtime we can change the consensus, the working consensus and all. So okay. These are the programming languages which have SDKs for Hyperledger Sawtooth. It has JavaScript support, Rust support, Go, Python, Java, and C++ support. The basically used one is JavaScript. So we have to have specific requirements for using JavaScript. You have to have an Ubuntu version of 16.04 special edition. So in Rust, Go, and Python, you have different requirements. So okay, and other are in development. They have a community and they are developing. Intel is basically now leading the development in Hyperledger Sawtooth. They are continuously developing new programs, and they also have an internship program which the basic developers could attend. So they are continuously developing, and totally there are about less than 2,500 blockchain developers in the world. And so there is a need for developing blockchain applications, but the number of people that are required to develop it are very less. So they are developing in different languages, and they have a community to promote the development of it. Okay, this is the basic life cycle of a transaction. So Okay, so when you have to send a specific transaction from Alice to Bob, this is what happens. Alice creates a transaction to give an asset to Bob. That is, Alice, considering Alice wants to send some bitcoins to Bob. So bitcoins is not in this concept, but just considering Alice wants to send an asset to Bob and sends it to the validator. So if you want to send an asset to Bob, if you can look in that Bitcoin basics, you can see that it passes through a validator. So each transaction passes through a validator, and each transaction is grouped into a batch. So the validator verifies the transaction. Validator does what it should do. It validates the transaction and it broadcasts it to all other validators. So it validates and it gives a copy to all other validators. After that, it builds a block of transactions. So after you validate it, a block is created, and these transactions or a group of transactions called batches, they are sent to a specific block. So they send the transaction corresponding. Okay. Then a validator is selected. So we have a set of validator, we have a consensus, and then a validator is selected. So ഒരു specific validator ഇത് validate ചെയ്യാൻ വേണ്ടി select ചെയ്യും. After it validates, it sends the block to other validators. So അങ്ങനെ ഒരു group of validators ഒന്ന് rotate ചെയ്ത് validate ചെയ്ത് വരും. So അങ്ങനെയാണ് ഈ chains create ആവുന്നത്. After that, ഈ chainsil പുതിയ transactions വരുമ്പോൾ chains extend ആവും. So അതിന്റെ copies എല്ലാവരുടെയും കയ്യിലുണ്ടാവും. Okay. After that, rinse and repeat. The same network creates a bunch of blocks, and from the starting point to end point, there are a number of blocks. So, first transaction with the final transaction, varayulla data completely hashed and completely secure ആയിട്ട് ഒരു group of validators ഉള്ളിൽ available ആണ്. ഇത് basic processes explain ചെയ്യണം. ഈ ഒരു സ്റ്റിക്ക് ഫിഗറിന് ക്ലയന്റ് ആയിട്ടാണ് വരുന്നത്. അപ്പോൾ ഈ ക്ലയന്റ് ഒരു ട്രാൻസാക്ഷൻ ഒരു സ്പെസിഫിക് വാലിഡേറ്റേഴ്സിന് കൊടുക്കും. ഈ വാലിഡേറ്റ് ചെയ്തതിനു ശേഷം അതിന്റെ കോപ്പീസ് എല്ലാവർക്കും അയച്ചു. അത് കഴിഞ്ഞ് നെക്സ്റ്റ് വാലിഡേറ്റേഴ്സിലേക്ക് പോകും. അങ്ങനെ ഷിഫ്റ്റ് ചെയ്ത് ഫൈനലി എല്ലാവരും വാലിഡേറ്റ് ചെയ്ത് കഴിഞ്ഞ് ഇറ്റ് ഈസ് ആഡഡ് ടു സ്പെസിഫിക് ബ്ലോക്ക്. ഓക്കെ, ഇവിടെ ഓരോ ബ്ലോക്സ് ക്രിയേറ്റ് ചെയ്തതാണ് സിംബലൈസ് ചെയ്യുന്നത്. And after the process is completed, they process for new blocks. Okay, so if you still have a slight problem understanding Bitcoin or these basics, we could just take a look. Okay. Let's take a look at Bitcoin.
Bitcoin is a digital currency which aims to do away with all the problems we have paying things online. You may think that the system we have is pretty good, but everything we buy today has to go through a bank or credit card company who take a cut of the transaction and who rely on our trust that they'll do everything right. After a while, those payments start to build up, and added to that is security. You have to trust your.
So during a basic transaction, you see the bank is taking away funds from you in terms of service charges. Also, you can see a hacker taking away the funds from you. So that is a really a big negative.
Many people have tried to work out how to have a payment system without that middleman. But then there's another problem. How do you prove that you paid something? Or even that you have that money at all?
Okay, this is a basic
Without someone vouching for you. It's so serious, it has a name. The doctor.
Okay, this is a basic problem which arises in the concept of basic banking, net banking. So it's called the double spending problem. So in case you send a specific amount of money to someone, you have to know, you have to contact or you have to have an API with the bank to confirm that the money is received to him. So you have to depend on a specific bank. If that bank is not accessible at the right time, you have to send it again. So this arises a problem called double spending problem arises. So
or spending problem. Then, in 2008, a solution was offered by an anonymous programmer going by the name of Satoshi Nakamoto. Nakamoto left a paper on a popular cryptography blog, which proposed a system of currency that solved all of these spending problems. His proposal was that instead of a bank or credit card company recording every transaction in one central ledger, all of the users would record all of the transactions at the same time. As a result, any attempt to fool the community would be noticed and the paper would.
okay, these are the validators. So each node on the network has to validate for a specific transaction to become complete. So that is the basic plus point of a cryptocurrency. So in case of faulty transaction, in case of someone sending a faulty transaction, every node in the network, every person knows that he has a copy of the transaction. So
Objective. No one user, government, or bank can force a fee on payment or control its flow. The result is a cheaper, quicker,
okay, the result is a cheaper, quicker, and around the world way to transfer transfer a particular amounts of money. So this has no limitations. So transfer or transactions via Bitcoin has no specific boundaries. In each country, it has the same rate because it is a digital form of currency.
an easier way to spend money, even across national borders. So this is Bitcoin, and it's already started having an impact on people's lives. Within months of the proposal, it was being used to buy and sell goods.
So when it was first proposed, Bitcoin was used for illegal transaction. So nobody can track you, right? So everybody is interested in illegal transaction. But the perfect way to use
Although
it
not
was
always from scrupulous traders. But it's not all shady businesses.
the perfect way was implemented in Ireland and Estonia for the first time. So they have Bitcoin ATMs and all. Recently, India has launched a Bitcoin ATM which was banned after 5 to 6 months of its proposed working day. So Bitcoin ATMs use digital currency as their output. So you can go to the ATM, withdraw a Bitcoin and use it for transactions. So it was firstly implemented in states like Ireland and all.
Some shopping sites take it. You can buy pints in London and even pay for your university tuition. As you might have heard, there are problems. While some are profiting from getting involved early, others are losing out in this volatile and young market.
Okay, so the basic problem that you're facing right now with Bitcoin is that you have a new technology and all the countries and all the parts of the world are not ready to accept it right now. For example, our country is a really good example for that. So we have a type of system that is that could be easily traceable. So the government is not ready to accept it. So we have problems like that, and that's why the economies are falling due to it. So we have different rates at different time intervals. So first it was about 800 euros, and it firstly bloomed to about 2,200 euros. So it changed a lot during the time. Basically, this was the problem.
And people are founding companies to buy up lots of Bitcoins. But as it's designed to have a limited amount ever in circulation, that might cause problems down the road. There's so much uncertainty around Bitcoin. Some people genuinely think this is the future. Others are terrified it could destroy our economy. But many from both sides agree that if we could get Bitcoin to work, or something like it, if we can trust a digital currency to work without the middleman, then the way the world economy functions could be transformed for the best.
We all know this.
So before we wind up this, are you interested in developing a Hyperledger project? Hyperledger Sawtooth based project. So I would like an answer. So I would give you the basic requirements that you need to launch a basic Hyperledger project. Okay, these are the languages. Okay, these are the languages and frameworks that you need to launch a basic Hyperledger base app. Okay, the first thing is NPM. The second thing, all of you are aware about all of this, right? NPM, Node, and Express. These are the basics for deploying a web app. And the next three things are Docker, Docker Compose, and YAML. Okay, YML is a basic YML or YAML is a basic extension, or it's called yet another markup language. It is similar to HTML, but it has certain extended functions. So that's what we use with Docker and Docker Compose. Okay. First of all, do I have to go through this? Okay. Node.js, it's a basic open source server environment. It's used to create servers. It's free, easy to run on various platforms, and uses JavaScript. Next thing is package manager, not package manager. We use it to download specific packages for Node. Okay, and the next thing is Express. Express is a framework for Node.js. You can use it for backend servers and web apps. And the next thing is for deployment of this application. So Docker, as the name suggests, is a place to hold containers. So Docker is designed to make an environment to run, deploy, and run applications using containers. So Docker is almost like a virtual machine. We use it to deploy specific containers. So, okay, Docker also has to use the same OS as the system. We have certain AI-based development environments like Anaconda for Python and all. So it's similar to that. It is a system or a environment that runs in the same OS. Okay. So the next thing is Docker images. These are the containers that we do. These are a set of instructions or a template which are used to publish things on the published environments on the Docker. Okay, we use a basic thing called Docker file, and these things are containers. It is the standard unit of software. These are the basic units of a Docker-based environment system. Okay. So the next thing is Docker Compose. We have certain environments and we have certain containers. So we have to bring all these containers together to create a virtual, completely trusted environment. So Docker Compose is what we use. So for creating or composing something using Docker Compose, we need a file called YAML file. YAML file is called yet another markup language or YAML is a markup language. It is almost similar to basic markup languages. So you can create and start with a simple command. So you just have to write Docker compose up space whatever file you have to whatever YAML file you have, and you just push it up and you get the container or the environment created to run Sawtooth. So you have any questions right now? Okay, so just if you have questions you can ask. So I would just give you the link to the materials. You can just note it down. You just take your Google Chrome and type this, and you get a drive link. And inside that drive link, you will get all these details, all the presentations and all. Okay, so thank you. So next day we could try to start something on Hyperledger. So thank you.
Thank you, Thank you very much for your wonderful session. Next, I invite Dr. Madhushandra Singh, HOD